So, ladies and gentlemen,
Thank you very
our
much.
next presentation is already the last one before our big lunch break. And this one will be given to you by a VIP of the ProStep IWeb Association and his colleague from Volkswagen. Martin Eigner is not only an expert for product lifecycle management, model-based system engineering, engineering processes, and industrial internet, but also a honorary member of the ProStep IWeb Association. And due to the circumstances that you all know, Martin, I'm going to skip the introduction and save some time for you. Martin, just 2 words about Philipp on this point. Philipp Heiner Schmidt has studied industrial engineering, and now he's working as head of product data management at Volkswagen. And he is your PhD student. That's how you met. And now you're going to talk about digital twins.
Thank you, Susanne.
Martin, I'm going to clear the stage for you.
I have to say, because we are in Germany, I can't say good morning. It's just a few minutes past 12. So in Germany, I worked for Bosch. It's from 12 o'clock, we shift from Guten Morgen to Mahlzeit. So Mahlzeit, ladies and gentlemen. So we will talk about Philipp, and I would like to talk about the digital twin in an environment. We call it System Lifecycle Management. I have introduced the term System Lifecycle Management 2012 as an extension or further development of PLM. But anyway, when you like the term PLM, use PLM. This doesn't matter. So we would like to show. Oh, I would like to see my slides. I see Philipp here, but I don't see my slides. So, hey, Philipp. Okay, it works. So thanks. Thanks a lot. We would like to start with, and still problems with shifting. Hey, doesn't work. So I can't shift them. Can you switch it manually, please? Okay. So we will start with 6 fundamentals. And I would like to show you one slide for one fundamental. So we will start with this slide. I think some of you will know the slides. It is the relationship between the term digital model, digital twin core, and digital thread. So the digital model in German, we call it the so-called 150% model. It's the order-neutral model. It consists of many partial models along the product lifecycle. At the end, after production, we have the so-called as-built BOM or as-delivered BOM. And this as-built BOM creates the digital twin core. That's the starting point of the digital twin. I will talk about this later. And the digital thread is a connection. You can see it's the red lines. Is a connection between all the information elements along the product lifecycle. So, next statement, reduction and enrichment of the digital core. We have seen the digital twin core is created out of the as-built and as-delivered bill of material. We get rid of a lot of information which are stored in the PLM or MRP environment. So we have a snapshot of the real product from the starting point. But we don't need all the elements of the bill of materials. If we get rid of unnecessary elements, for example, the windshield wiper, which could be exchanged from the driver or the owner of the car, we can get rid of the windshield wiper and a lot of other things. So that is the reduction of the digital twin. On the other side, based on a service-oriented digital model or business concept, we can enrich the digital twin core. And there's a study from Gartner Group that many legacy systems from the enterprise are able to enrich or to add information to the digital twin. That could be an MES system, a quality management system, or whatever. So enrichment and reduction, the second statement. The third statement, very easy. If you have a product based on variation, typically in automotive industry and aerospace industry, the digital twin is configured out of the product variation based on the option code you have selected as a customer and the actual status of the engineering change management, so the actual configuration. The identification of the digital twin is very easy. It's the selected option code, the serial number, the part number, and the revision. That's the unique identification of the digital twin. Next statement. The digital twin has different types of behavior. So we are starting in the early development, we are starting with the simulation twin. And it's a time we even have no prototype, we have no physical twin. So we start with the simulation twin. We come to the prototyping twin. In the early development phase, we have the production twin. And once again, after the release of the product, after the production as built, as delivered bill of material, we start with the operational twin or the so-called service twin as maintained. And the service twin, typical once again, is a prerequisite for a service-oriented business model. Next statement. That is I think I would like to explain in a very easy slide what is the base principle of a digital twin. So once again, we have a digital twin created out of the MRP or PLM system. We have a one-to-one relation to the physical twin. We have the enrichment, the reduction. The physical twin is equipped with a lot of intelligent sensors, and intelligent means the sensor is connected to the internet, and the sensor is able to filter the data stream in advance. That does mean only data are sent to the data cloud or the business analytics that are deviated out of or deviated from an average value or a bandwidth. The data from the data cloud must be interpreted. So we talked about business analytics. It's a little bit a buzzword. The business analytics consists of monitoring, reporting, control, and analysis. We are strong in the first three. We are weak in analysis. That analysis is just a huge research area where we try with artificial intelligence to interpret and evaluate the lot of data coming from the physical twin. And of course, reporting, control, monitoring means we need the type of visualization. We have to show all the different data streams, the results. We have to build up an easy graphic, and you can see at the end we are using the data for service decision, maybe in a business model for predictive maintenance, or we are using the values for feedback in the R&D department. So, Philip, take over. It's our big picture from the digital twin.
Yeah, thank you. In this context, Martin mentioned, we would like to present our current state of work on a definition of a digital twin. Martin mentioned a lot of that, Sean, before. A digital twin for us is a representation of a physical or non-physical product, service, or process from the real world in the digital world. And we are only speaking about twins if there is a digital and a physical counterpart. And the basis in our eyes must be the digital model or digital master, because that's where all the descriptive data is managed. You can see it on the left side. And from this digital model, you can instantiate by an order the digital twin core. And the digital twin core contains the BOM and other describing data which are necessary for a specific use case. This digital twin core, represented by the green symbol, can now be enriched with further data, and a distinction must be made between data that is permanently linked to the core, represented by the red symbols. This is data, or this permanently linked data serve to describe the digital twin core in more detail. This can be, for example, position information for a component. And there is data that is not permanently linked. This is maybe demand-driven linked. This is data which is necessary for analysis or something like that. This data originates in other IT systems like ERP, CRM, MRO systems. You can see it on the top of the picture. And yeah, there are a lot of bidirectional data streams between the digital and the physical twin. This enables the interaction between these two. The picture you can see contains even more details, but I think this is enough for this presentation. As a summary, we have presented here the written definition. You are welcome to read it when the slides are distributed. And with that, I give back to Martin.
Yeah, thanks, Philip. And you can read the definition at home, so we wouldn't like to present text in a graphical presentation. So the next big topic is 2 slides related to System Lifecycle Management, or when you would like to call it PLM. Maybe you know this slide. It's a direct derivation from slide 3, the digital model, digital thread, and digital twin core. It's the IT architecture, how we realize right now in huge companies in automotive, aerospace, machinery industry, ship industry, medical industry, we realize the backbone concept. You can see the integrated horizontal backbone. Typical, all the engineering processes like change management, configuration management are running on the backbone, and you can see the vertical, particular and partial model-related vertical integrations from the authoring system via team data management into the backbone. I think what is interesting, the next slide. So you should not imagine that the SysLM is a monolithic big monster. It's a flexible, federated, scalable system right now. A modern, Gartner Group is calling this type of system bimodal IT systems. You can see here is a typical environment of a customer, and you, at the end, what we have to show is definitely all the configured item, all the related information along the product lifecycle, from the requirements of the system behavior, logical design, system architecture, engineering, production, and so on. So I can, and it's interesting, for example, we have shown two solutions. The blue solution, for example, excludes the MBOM and the manufacturing process plan. It's part of the MRP environment. On the other side, the blue solution has integrated the system architecture. That doesn't matter. At the end, the system is able, based on the technology and architecture, to integrate, to federate all the interesting data related to the product. So the typical technology and architecture you can see on the slide, very important, is web services, microservice, multi-tenant database, and so on. So now we would like to show you at the end 3 examples. One example from an industrial approach, the second example from an PLM, SysLM supplier, and the third example, I like it very much, is in one of my last research projects on the university. It's in the autonomous construction area. So Philipp, once again, take over.
The first example is about instantiation. At Volkswagen Commercial Vehicles, we have been dealing with the question how to instantiate digital twins for our prototypes. And there are 2 main drivers for the complexity of this question. The first one is most of the processes in prototype construction are hardware-driven. For example, the definition of the release dates. Starting with a building date of the physical prototype, we are back calculating by the procurement time of each component and define the release date. And this leads us to a spread of 9 weeks for all release dates for the prototypes. And then the question arises, where's the right time for instantiation? At the beginning of the 9 weeks, at the end of the 9 weeks, in the middle, because the digital model is living and changing every day. And the second driver is the digital model, you can see on the top of the picture, represents a series production with the aim, for example, an ID bus. But our prototypes often deviate from this and have other components or parts, or as shown in the picture, a completely different body. And for that reason, we insert a digital model prototype, especially for one prototype fleet. And I like to explain that to you. What we have done, on the top, you see the digital model or digital master with its product structure. And on the bottom, you see the digital model for one prototype fleet. And at the beginning of the 9 weeks, we are copying the product structure from the digital model. And if something changes in this 9 weeks, it can be decided whether this change is relevant for the prototypes or not. And then we can adapt it, or we can ignore this. And in the end of the 9 weeks, the product structure for the prototypes is frozen, and we can use it for instantiation our prototypes. Okay. Yeah, and in order to instantiate fully described prototypes, or digital twins for prototypes, we handle the other data as follows. We take the variant management from the digital model and we adapt all changes. Otherwise, we have inconsistencies and instantiation would not be possible. And for the mechanic, EE, and software data, we have a release workflow. and we flag the relevant revisions of the parts and for the hardware and software revisions. And this enables us to instantiate prototypes of digital twins of our prototypes. Yeah, thank you. And now example 2 from Martin.
Yeah, thanks, Philip. The next example is based on SysLM providers, ours. Very easy. So I have simplified it as most as possible. We detect a sensor error, we log the problem based on a problem report, a service bulletin. We replace the faulty sensor, and we initiate a CAPA, corrective action and preventive action items. So the example is very easy. You can see in the green box the original digital twin representation. So we create an bulletin, a service bulletin, and a problem report. And on the right upper border, you can see the so-called, I call it engineering Twitter, where we can communicate. It's like Facebook or like Twitter, so you can integrate your colleagues in the discussion process. What is the solution for this type of problem? We exchange the faulty sensor. You can see it. The red one is deleted. We got a new one with a new serial number. And now we are starting the CAPA action. We have to find out where this potential faulty sensor is integrated in a customer base, and we can select the serial number of the robot, and then we can do the right decisions. The next example is from our research area. We have created many happy students. They can use Lego Milestone, Raspberry, and BrickPy. And it was very interesting. We simulated autonomous construction area. So sorry, we have to take, based on my university budget, we have to use Lego. And at the end, I would like to show you the result. We used for the visualization. I think it's very important to visualize the result of the physical data stream. And you can see all the data coming out of on the Lego environment. It's really autonomous. And it's based on contact elements. So thanks a lot. Thank you for all the attendees and for listening to us. And now I'm open for all the questions coming up.
And of course, there were some questions coming in. Martin, Philip, thank you very much for your presentation. And luckily, we still have time for a little Q&A. So I would say let's jump directly into the topic. The first question comes from Markus Schacher. What is the difference between a digital twin of a process and a digital thread?
Oh, it is very different. So I think the digital twin of a process and a product is very similar. For example, we have initiated a project in Berlin. We call it Garbage 4.0. That was a service-oriented business model with the service-oriented digital twin. I think that is not the difference. The digital thread, the connection between digital twin and digital thread is if you have a faulty sensor, like this example, then you can keep track the digital model. What are the related information elements? So that's totally different, but they are connected. You need the digital thread to create an impression. What is the reason for the faulty sensor? What's happened there?
Wonderful. So Rainer has also sent us a question from Berlin. By the way, I was really funny to see what's going on in the chat. Everybody was like, oh, it's so good to see Martin again. That was really amazing to see. So the question from Rainer is, where do you suggest to conduct which kind of analytics to make effective use of running a digital twin?
That is Rainer, my friend Rainer. Good question. Good question is a stupid answer because I have not a real answer. We are just in the area of industrial research. What we do, what I mentioned is we try to use intelligent sensors because when you see the data stream coming from an Airbus, from an airplane, everybody is bored because a lot of digital data streams and you can't analyze it. What we try to do, and that's what I mean with intelligent sensors, we would like to reduce the data stream only on values which are deviated from the average and defined with bandwidth. That is the first step. So we will kill the data, we will kill the analyzers. That's the first thing. The other thing, my opinion is, we are just in the beginning of the real analytics based on artificial intelligence. We have to learn. We have to learn. Artificial intelligence is to transfer mental human learning into information. Yeah.
Absolutely.
And that's something we have to do. So Rainer, so sorry, I have no solution.
We're
But we are
still
working-
very
we are
much at the
working.
beginning.
We are
You're absolutely
working.
right,
Yeah,
Martin.
yeah.
So we have 30 seconds left for a last question that comes from Thomas. Thinking about legal-like composable architectures, what is your opinion on interacting digital twins? So I mean, what will interfaces between digital twins look like?
The interface between digital twin, I don't know whether I have. I think in the last example, there is a relationship. We describe the behavior of the autonomous construction area based on a system architecture. It was Cameo, System L. So we described the behavior and we simulated it in Modelica. I think that is the relationship. We have not used CRE because we use Lego. That was a set we built together. So I don't know whether this answers the question, but I hope. Yeah. So they are always related. The digital twin is related with all partial models of the digital model. That's all what I can say. Yeah.
Perfect. Martin, Philip, also to you, thank you very much for joining
Thank
us
you.
remotely. And Martin, thanks for being on stage.
Thank you, sir.
So, ladies and gentlemen, it is already time for our lunch break. That have been 2 intensive hours, I know that. It has been plenty of input. So please use the break to refresh your brain, to eat a little bit, but also make advantage of the opportunity to get in contact. It's about networking, networking, networking. That's why we do a 2-hour break, so you have plenty of time for that. That means it's now time to switch to the Engage area where you can meet other participants, our exhibitors, you can make appointments, so really make use of this great opportunity. By the way, I totally recommend our filter function, so you can look after names, after companies, after industry sectors. You're going to find the right people you want to get in touch with. Take advantage of that. You have 2 hours time. We'll be back at 2:20 with our award ceremony and, of course, even more content. See you later.